Last section of probability. We have this thing called conditional probability. And it's usually given like this with this line right here. That's saying given that this already occurs. Given that when I'm looking at my classroom, I know that someone is a boy, then what's the probability that I would pick someone with blue eyes? So knowing that already, it changes the total. That's what this given that conditional probability. So all these probabilities look a little different. You have to be able to read what's going on first. Finding the conditional probability. What I'm going to do first is figure out the totals here because it will just make it faster. So I have totals again. It's just going to make it easier while we go through these questions. This first question is saying, what's the probability you're going to pick a female? Given that this line means given that it's a graduate student. So already it's cutting down our total, our option. So given that it's a graduate student, it's going to be one of these two numbers. So I had to figure out my total graduate school people. So my total graduate is this 3303. So that's my total. That goes on bottom. So given that for sure they're graduate students, once you cut it down to just this total, that means it has to be one of these two numbers. Saying what's the probability that they're female and a graduate student, knowing that you're picking from graduate. So the 1954 on top. And a lot of times with these problems, I'm sorry, you would want to change this into a percentage. So I'm going to say that this decimal, remember you move it 2 times to the right, would be 59.2%. 59.2%. This question is saying, what's the probability it's female? There's no other question there. What's the probability that in all of these people that you're choosing, what's the probability that you pick female? So now this box right here is my total. It's all of these numbers, these 4 numbers added together. So this is my total number. So my total would be 17472 because I'm looking at what's my total out of all these people, what's the probability that they're female? So I have to add up all my females. So it could be any one of these would make that statement true. So all of these added together would be 9933. What's the difference between the two of these of why you take the total? So 9933 divided by 17472. So this is going to be 56.9%. 56.9%. So the difference between these two is saying, this one's saying, given that for sure no a graduate student. So given that it has to be out of this section. This one's saying just female. So looking at the whole chart, so that's taking the total of everybody in this chart. This last one, given that it's male. So what's the probability that their 4-year student, so here's my 4-year, given that it's male. So I know for sure that's going to be someone from the male. So here's my total of male. So it has to be one of these 3 because I for sure know it's going to be a male. So I have 7539. 7539 because I know for sure it's going to be a male. What's the probability you pick someone that's a 4-year male? This is the only one that's 4-year and male. So 4324. And again, when you put this in your calculator, 4324 divided by 7539, that probability would be 57.4%. 57.4%. So right now, again, it'd be easier if you count the totals first. So the first question saying, what is the probability that a sample of recycled waste is paper? So given that you for sure know it's a recycled waste. So here's the probability that you know it's recycled waste. So this would be my total. It could be any one of these. My 79.4 goes on bottom. What's the probability that knowing that it's recycled waste, what's the probability that would be paper? So recycled and paper will go on top. So 45.2, especially for a problem. You should never have a decimal inside a fraction like this. So you should always make this into percent. This is going around to 56.9, 56.9%. Remember, when you're finding your percent, you're moving your decimal point 2 times to the right. What's the probability the sample of recycled waste is plastic? So again, we know for sure it's recycled waste, so it's going to be one of these. My total is still going to be 79.4. What's the probability that would be plastic? So 2.7. So it looks like the majority of stuff that's recycled is paper. So 79.4. So this, again, if I move this 2 times to the right, I have my decimal point right here. So it'd be 2.6. 2.6%. What's the probability that a sample of recycled waste, so still the same category, so my total is still 79.4, what's the probability it's going to be glass? So my total of glass recycled is on top. So 3.2 divided by 79.4. Again, if I move my decimal point 2 over to the right, this 3 does not move that up, so it'd just be 4% because I have that 0. If it says to have a decimal, you can have a 0 right there also. So these are just more conditional probabilities. I want you to try this first one by yourself. So given that the customer is male, so it's going to be one of these two, so that total male goes on bottom. What's the probability that it's going to be pay online and mail? So this is the number that's pay online and mail. So that'd be 60%. Try B by yourself. So again, given that they're going to be female, so it's going to be this total right here, that goes on bottom. The total female goes on bottom. What's the probability they apply directly to their head? And then, that's weird, just to let you know. 6 people do that. So 6 out of 30 would be 20%. I don't know. I think maybe I should take my own poll about who applies shampoo directly to their head. So next one, a senior class is 55% female. 32 of the class are females who play competitive sports. So this is like and. This is my and statement already done. What's the probability that a student who plays a competitive sport, given that they're female? So this is my total female. Female is 55%. So this is female and competitive sport would be 32. So again, when you have a given that statement, given that they're female, that total goes on bottom. And you can use percentages. And then the on top is the 2 together. So female competitive sports would be 32. So female competitive on top, just female on bottom. So if I do 32 divided by 55, I get 58.1%. Okay. First, we have to be able to read this chart. This is saying 52% are juniors. So if you want to pause, you want to read this. 48% are seniors. Knowing that they're juniors, out of those juniors, 35% are employed, 65% are unemployed. The seniors, 55% are employed, 45% are unemployed. So first thing I'm going to do is multiply this across because it's an and statement. What if I want to figure out how many total people are juniors and employed? I would have to multiply this. Juniors and employed, I multiply those together. Remember that and statement. So 0.182% would be juniors and employed. If I want to figure out if they're juniors and unemployed, again, I multiply 0.52 times 0.65, and I get 0.338. What I'm finding right now is the probability of junior and employed, if I pick someone at random, a junior and unemployed, if I pick someone. Now, if I look at my seniors, I take the probability that they're senior times, because it's an and statement, the probability that they would be employed. So I'm multiplying those together, 0.264. So I'm multiplying probability that they're seniors and the probability that they're unemployed, 0.216. So now I can actually answer all these different questions. So this first question is saying, what's the probability that you pick someone and they're employed? Well, if I pick someone and they're employed, they could either be a junior or they could be a senior. Or statement, when you have your or statement, remember, you are adding them together. So I'm looking at my 2 employed probabilities, and it's an or statement, I add them together. Oops, I plugged it into my calculator incorrectly. So 0.182 plus 0.264 would be 0.446. Probability would be 0.446 if you pick someone that's employed. This is saying find the probability of a junior and unemployed. We already found that. Here's our junior and unemployed. So if you were going to pick someone at random, you pick junior and unemployed would be 0.338. You could change this into decimal or percentages if you want. So this one's a little bit different. This is saying, given that they're employed, so here I already found that. So that will be my total. My probability that they're employed is going to be my total. Given that they're employed, what's the probability that they're a senior? Remember, the number on top is where these two collide. So on bottom is just the probability of finding someone who's employed, adding those two numbers. On top is senior employed. So senior employed would be 0.264. Again, senior employed. So you do not want to have your decimals in your fraction. That'd be no good. So 0.592. So given that they're employed, the fact that they'd be a senior would be 0.92. Here, before I can do anything, I have to figure out the probability that they're unemployed because I need that total. So if I'm looking at my probability that they're unemployed, a junior unemployed is 0.338. Or, so adding, when you get or, they could be senior unemployed, 0.216. So if I add 0.338 plus 0.216, I would get 0.554. So looking at given that they're unemployed, so that's my total on bottom, given that they're unemployed, total on bottom, what's the probability that they're juniors and unemployed? So this is the only option for juniors and unemployed. So if I do 0.338 divided by 0.554, that would be 0.610, so like 61%. I want you to try to do these last two by yourself. Try to do these last two by yourself. So here, given that they're unemployed, we already found that right over here. The total unemployed, what's the probability that they're senior unemployed? Again, senior unemployed is 0.216. So I divide those two fractions out, I get 39%. What's the probability if you know that they're already going to be employed? So we already found that total here. Here's the total people who are employed. What's the probability if they're junior employed? So junior and employed, 0.182. So if I divide those out, I get 0.408. There you have it. Yes, I get that this bottom or this last page is confusing, but we will be practicing also in class. Have a wonderful day.